Okay, so here we are on our sample problem number 2. Wayne Gretzky hits a stationary 0.12 kilogram hockey puck with a force that lasts for 1.0 times 10 to the negative 2 seconds and makes the puck shoot across the ice with a speed of 20 meters per second, scoring a goal for his team. With what force did Wayne hit the puck? Okay, so right away we see we have 3 given pieces of information and we are looking for force. So this is an example of an impulse. We're changing the momentum of the puck. The puck was stationary, so it had 0 momentum, and we're going to put it into motion. So let's start with our sketch. Here's the sketch I created. Actually, I'll do my sketch and my information. So there's Wayne Gretzky with his hockey stick. He's hitting the puck. The puck's information is there. It is 0.12 kilograms. It's going to move with a velocity of 20 meters per second, and the amount of time the force is applied is written down. It enters the goal, and he scores. Okay, so the givens are mass, velocity, and the amount of applied time or elapsed time that the force is applied. What is unknown is our force. Everything looks good in terms of units. We have everything where we want it to be, so there's no conversions necessary. This is not a double-step problem. Okay, so what are we doing with our equation here? Well, our equation is impulse equals change of momentum. So F delta T is going to equal M delta V. And that's our original set of equations. We need to manipulate to solve for force. So by doing that, we are going to move the delta T or elapsed time to the other side of the equal sign. By dividing it out, since we're multiplying it on the left, we do the opposite and we divide on the right. So F equals M delta V over delta T is our new equation. How do we solve it? We plug and chug. Okay, force equals 0.12 kilograms times 20 meters per second, all divided by 1.0 times 10 to the negative 2. We get force is 240 kilogram meter per second squared. Okay, that's because meters per second on the top there and velocity, the second is in the denominator. Dividing again by seconds makes it meters per second square. We know from the past that a kilogram, a mass times an acceleration, right? F equals ma, Newton's second law. Mass times an acceleration, meters per second squared is an acceleration, is going to give us a force which is measured in newtons, and that is why we end up with the newtons as our unit. And we put a box around it to show the answer. And that is example number 2.